So before I start this lecture, I would ask you learners to please like, share and subscribe to Med Learning and also hit the bell icon so that you will be notified about our future videos. With that said, let's begin our lecture. Hey there guys, Shami here with another Med Learning video, and today I'm going to talk about pharmacology, and this is the part 1 of our pharmacology introduction lecture. In this part I'm going to give a little introduction about pharmacology, and in the second part I'm going to talk in detail about pharmacokinetics and pharmacodynamics. So stay tuned for that video. But for this video, let us move to the first slide. I'm going to talk about the objectives. So at the end of this lecture, learners will be able to, first of all, we are going to define what is pharmacology. We are going to understand a little bit about the history of pharmacology. I'm going to define drug and its classification. I'm also going to discuss a few terms which are very important and pertinent to pharmacology. And I'm going to define drug nomenclature and we are going to understand its importance. So if I quickly move to the first slide. So what is pharmacology? So pharmacology essentially is derived from two words, pharmakon and logia. Okay. So these are Greek words and pharmakon means poison or drug. So in Greek, drug and poison is essentially the same thing. So pharmakon is essentially the name derived for a drug or poison, and logia is the name also called study of. So in this way, we can call that this is the study of drugs. So essentially what is pharmacology? Pharmacology is the branch of medicine which is concerned with the uses of drugs, the effects of drugs on body, and the body's response to those drugs. So what we are talking about here is that what is the use of a particular drug, why is it used, what it is used for, what is the effect of that drug on your body, and what is the body's response to that particular drug. So this is what essentially pharmacology is, and that is what we study in pharmacology. So pharmacology is as primitive as man, and man has gathered the knowledge of healing and medicine by observing nature, also noticing animals while ill, and using different herbs and berries as remedies. And this has been true for people as primitive as man itself. So if I talk about a particular personality, I'm going to talk about Hippocrates, who was alive from 460 BC to 377 BC, and he is also called as the father of medicine. And what he did was that he separated the practice of medicine from religion and superstition. So earlier, usually the practice of medicine was linked to religion and superstition, what people believed, what people thought as is true for the masses. That is what medicine evolved around or revolved around. So, but he separated it from that part of the human culture or human practices. And essentially separated that, and he is therefore called the father of medicine. Also, traditional medicine practices have been around for many thousands of years. So if I move to the next slide, I want to talk about what is drug and what is the basic definition of drug, what is the basic function of drug. So drug is anything that brings biological change through its chemical actions inside a body. So a chemical substance which is used in the treatment, cure, prevention and diagnosis of disease and used to enhance physical and mental well-being. So a drug is basically a substance or a chemical substance which is used to treat, cure, prevent and diagnose disease. Okay, and it also enhances physical and mental well-being. So this is simply what a drug is. So if I move to the next slide, I'm going to talk a little bit about the classification of drugs. So there is no essential way to classify drug, and drug classification basically depends on the person or the convenience of a person. For example, a chemist may classify a drug in a different way, a pharmacologist may classify it in a different way, a pharmacist may classify it in a different way, and the same way a clinician may classify it in a different way. So the drug classification is not coherent, it does not revolve around a system, or it does not have a meticulous system. That it is basically classified according to the convenience of a person. And if I talk about a particular classification of drug, there are a few ways why we can classify drugs, and this can be based on the chemical nature of the drug, can be based on the source of drug, where the drug is extracted from or taken from. It can be based on the site of action or the target organ on which that drug acts on. It can be based on the mode of action of a drug. It can be based on therapeutic uses. It can also be based on physiological system, on which physiological system the drug acts. That can also be used to classify a drug. And the physical effects. What are the physical effects of a drug? So if I talk about a particular classification, I can talk about the therapeutic classification. Therapeutic classification of a drug is essentially the type of effects that a drug produces, or the type of clinical or beneficial effects that a drug produces. So if I talk about a few examples listed here, for example, analgesics are essentially the drugs which act against analgesia or pain. Therefore, they are called analgesics. So this is a therapeutic classification. If I talk about antacids, these drugs are acting against the acids, therefore they are called antacids. There are quite a few examples. If I talk about like anti-anginal drugs, these drugs act against angina or heart pain, therefore they are called anti-anginal. So there are quite a few examples listed here, and this is essentially again a clinical classification or classification of a drug acting on a particular area of the body or a particular substance or organism, and it causes opposite effects or it acts against that organism. Therefore, it is called therapeutic classification. If I talk about a few definitions that are essential to our understanding of pharmacology, then the first one is called indication. Indication is essentially reason for administering a medication or performing a treatment. So if we are doing something, if we are giving a medication, we want a certain effect, or we see a particular reason for giving that drug or administering that drug, and this is called the indication. If you talk about the contraindications, it is basically the opposite to indication, and it is the factor that prevents the use of a drug or a treatment. For example, allergies, they can be very important factors for not using a drug or for prohibiting the use of a drug. So contraindications are essentially the factors that prevent the use of a drug. Okay. If you talk about effects or therapeutic effect, effects are essentially the desired results of a administration of drug. So they can be like any effect that we want. For example, if we are giving a pain medication, we want the desired effect is as the decreasing pain. So this is the desired effect that we want out of that drug, and that's why we are going to administer that. So if I talk about the picture here, which is present, I'm going to talk about the risk benefit ratio that is written here. And we are always doing this when we prescribe drugs or we give or administer drugs, that we are weighing these risk and the benefit ratios. That, for example, if the risks are adverse effects, costs, and inconvenience, then the benefits might be reduced morbidity, improved quality of life, effectiveness, and ease of administration. So here in this particular case, the benefits outweigh the risk, therefore we can go forward with administering the drug. But if the benefits don't outweigh the risks, and if the risks are greater than the benefits, then we might not give the drug. So we are always doing this quantification. We are always doing this using this scale, like to quantify these decisions and to understand what we are trying to do. So if I move to the next slide, I want to talk a little bit about the few other important definitions about pharmacology, and these are, first we have side effects. So side effects are essentially the harmful or the undesired effects. The effects that we do not want are the adverse effects. So this is not a very difficult concept to understand, that the harmful or undesired effects that occur due to a medicine are the side effects. And what is duration? Duration is the time a drug concentration is sufficient to elicit a therapeutic response. So if we are giving a particular drug concentration, then what time is sufficient to elicit a particular therapeutic response by that drug concentration? That is called the duration. So if we are giving a particular concentration, if we give drug in a particular concentration and it has a certain time, for example, if we are giving like 0.5 grams of a drug, and the time it takes for that drug to elicit a therapeutic response is 30 minutes, then if we give 1 gram of that drug and the time goes down to 15 minutes, that the duration changes. So this is essentially what a duration is, that the time it takes for a particular amount of a drug to produce its therapeutic response. If I talk about onset, onset is the time it takes for a drug to elicit a response. So this is basically the time it takes for a particular drug. It does not care about concentration. The time it takes for a particular drug to make a therapeutic response or elicit a therapeutic response. So this is onset. So it can be 30 minutes, it can be 1 minute, it can be 10 hours. Okay. So this is essentially what onset means. So if I move to the next slide, I'm going to talk a little bit about the sources of drugs. So we have quite a few sources from which we derive our drugs from, and a few are listed here in this slide. If I talk about the first source, we have plant sources, and this is essentially the digoxin, for example, digoxin, which is derived from digitalis. So digitalis is a plant from which we derive the drug digoxin, which is an antiarrhythmic drug. And if I talk about another drug, morphine, morphine is a very potent painkiller, which is derived from opium. So these two drugs are derived from plant sources. And if I talk about the animal sources, we have very different glandular products which are derived from animals, such as we have insulins and thyroids. So insulin can be derived from animals, and thyroid can also be derived from animal products. And if I talk about another drug, I would like to mention albumin, albumin which is used in like chronic liver disease patients. And these type of patients have liver disease, therefore they do not produce the albumin which is essential to the body. So albumin is used to treat these patients, and it is also derived from animal sources. And if I talk about microorganisms like fungi and bacteria, so penicillin is like the most famous, is one of the most famous drugs ever, and it is basically an antibiotic which is derived from a product called penicillin notum. It was basically a mold which was discovered by Alexander Fleming in 1928 from a mold that was growing in his lab. And we have quite a few other drugs as well that are derived from microorganisms. If I talk about minerals, for example, lithium carbonate and MgSO4. Lithium carbonate is an antipsychotic and MgSO4 is a laxative. These are derived from mineral sources. If I talk about man-made or synthetic sources, we have sulfonamides, which are antibacterial agents used to treat various different infections, and aspirins. And aspirin is used to treat also, it's used as an anticoagulant, used to treat strokes and MIs and different heart conditions. And we have recombinant proteins, and recombinant proteins which are like re-engineered or derived from different DNA sources. These are interferons and antibiotics. So these are all the different sources that we derive our drugs from. And if I move to the next slide, I want to talk a little bit about drug nomenclature. So drugs basically have three different names, and drug nomenclature is the way we identify a drug. So we identify a drug via these three names. First is the chemical name, second is the non-proprietary name, and the third is proprietary name. So if I talk about a few of these, first I'll talk about the chemical name. So chemical name is basically the name which is given when a new chemical entity is developed, and it is mostly used by chemists and other technical personnel as well, and it is based on the precise arrangements of atoms and atomic groups in that particular entity or molecule. It is also not used to identify a particular molecule or a particular drug in a clinical or in a marketing situation, because it is just too cumbersome and just too difficult to pronounce those names. So if I give you a particular example, I want to give you this example in the next slide because I have written it in the next slide. So a particular example can be of metronidazole. So we know metronidazole is a famous antibiotic, and its chemical name is 2-methyl 5-nitromidazole 1-ethanol. So this is basically two methyl groups which are attached to 5-nitromidazole groups and 1-ethanol group. So this is basically a chemical name of that particular drug, which is also called metronidazole. I'm going to talk about that in a little bit, but this is essentially what a chemical name is. So it consists of different atomic groups and different molecules that are attached to one another via different bonds, and therefore it is called the chemical name. But if I move to this slide, which is the generic name or the non-proprietary name, it is basically a name which is simpler from the chemical name itself, and it is easier to remember. So everyone can remember it easily. So if I talk about a particular drug, again I'll talk about metronidazole, which is 2-methyl 5-nitromidazole and 1-ethanol, and it is condensed like the methyl nitro is condensed to metro, and nidazole it is condensed to imidazole. So it becomes metronidazole. Okay, so this is a generic name, and it is also the universal name used by different clinicians and basically used everywhere around the world. So if I talk about the last name that is used to identify a drug, or is the part of the drug nomenclature, is the brand name, and it is also called the proprietary name. It is basically the name given by a particular firm or a particular pharmaceutical company that sells the drug, and it becomes the exclusive property of that drug because only they can sell that drug on that particular name. For example, we have Flagyl, which is the trade name for metronidazole. Like I've listed a few names of companies here. So if, for example, Roche, which is a pharmaceutical company, has the trade name for metronidazole as Flagyl, that they sell metronidazole under the trade name of Flagyl, then only they can sell that particular drug under the name of Flagyl. A company like Novartis cannot sell that drug under that same brand name. So only those particular companies who sell that drug have the trade name, the authority to sell those drugs under that trade name. And it is also written with a capital letter and are also and often further distinguished by superscript or R in the circle R, as it is mentioned here in these examples. So if I give a few other examples, I want to give Metaclone, which is the trade name for metoclopramide, and Panadol, which is the trade name for acetaminophen. So thank you guys for watching this video, and I'm going to release a part 2 of the introductory video on pharmacology, so stay tuned for that. And if you like this video, please like, share, and subscribe to Med Learning. Also hit the bell icon so that you will be notified about our future videos. With that said, I'll see you in the next video. Bye bye.